The 8051 microcontroller is a tiny computer developed by Intel in the 1980s. It is used in many electronic systems like cars, medical devices, etc. It has two memory spaces, one for program memory and the other for data memory. The program counter can access up to 64K of program memory, while the data memory has 128 bytes of internal RAM and up to 64K of external RAM. The microcontroller has four functional blocks: the CPU, memory, input, output ports, and serial communication interface. It comes with many built-in tools that can be used to interface with other devices, making it an excellent choice for many embedded system applications. The 8051 microcontroller is a widely used 8-bit microcontroller known for its versatility and low power consumption. Its architecture is based on Harvard architecture and includes a range of features such as timers, interrupt handling, and serial communication interfaces. Let us discuss the architecture of the 8051 microcontroller architecture in detail. The 8051 microcontroller architecture consists of the following major components. Interrupt control. It supports 5 interrupt sources, which can interrupt the normal program execution to handle specific events. Central Processing Unit, CPU. This is the brain of the microcontroller, which is responsible for executing instructions and performing arithmetic and logical operations. The 8051 CPU consists of an ALU, accumulator, registers, and a program counter. Oscillator. It requires an external oscillator to provide a clock signal to the microcontroller. Bus control. The 8051 microcontroller includes a bus controller that manages data transfer between the CPU and peripheral devices, such as memory or input-output devices. 4K ROM. The 8051 microcontroller architecture includes a 4 KB, 4K, read-only memory, ROM, for storing the program instructions that are executed by the CPU. 128-byte RAM. The 8051 microcontroller also has a 128-byte random access memory, RAM, for storing data that is used by the program instructions during runtime. Input-output ports. They have 4 8-bit input-output, I/O, ports that can be configured as either input or output. Timers and counters. They have two 16-bit timers/counters that can be used for a variety of tasks such as measuring time intervals, generating PWM signals, and counting external events. Serial Communication Interface, SCI. It has a built-in serial port that can be used for asynchronous serial communication.